We're going to look at thermoregulatory fatigue very quickly. There are 3 fatigue mechanisms in the body, the reasons why we become fatigued, although we look at fatigue as being a multifactorial mechanism. The 3 fatigue mechanisms are fuel depletion, accumulation of metabolic byproducts, and thermoregulatory fatigue, which refers to an inability to maintain a stable body temperature. It might be that the body is too cold, but more often for VCEPE, we look at it being too warm. Now, what happens is when our body is unable to maintain a stable body temperature and it becomes too warm, we sweat. We sweat to try and cool down. And when we sweat, we become dehydrated. So thermoregulatory fatigue is the mechanism and dehydration is the result. Thermoregulatory fatigue is the term you should be using. Thermoregulatory fatigue, an elevated body temperature. When we exercise, we produce heat as a result of aerobic metabolism. Heat is a byproduct, and normally we're pretty good at getting rid of it. Our normal body temperature ranges from 36.5 to 37.5, and any variance outside of this temperature means that the body isn't going to function as well as it possibly can. What we do when our body temperature starts to rise is we need to bring it back down, and we do so via sweating. Most of the heat loss from our body occurs via this way. What happens is we lose water off the surface of our skin, and that acts as a cooling mechanism. A good way of thinking about this is when you're at the beach or when you're at a pool on a really warm day and you come out of the water, and even though it's really warm, you feel quite cool when the wind comes across you. And the reason why that happens is that it evaporates and it cools you down. Now, in humid environments, so when there's a lot of water in the air, that is less effective. It doesn't evaporate as quickly or as easily, so we have more trouble regulating our temperature. When we lose water from the surface of our skin, the blood goes close to that site because that's where the cooling is occurring. So in order to regulate our temperature, the blood, which is carrying the heat, moves to the surface of our skin to try and cool down. This itself causes problems. We'll talk about that later. When we sweat, we lose that sweat from our blood. It's actually our blood plasma. What does this mean? Well, it means that when we lose part of our blood, we lose some of our total blood volume. Our blood becomes a bit thicker, which means that it has problems. Let's look at that. The idea of cardiac drift refers to this exact mechanism. So when we lose our blood plasma through sweat, we get a decrease in total blood volume. This means that because we don't have as much blood, our body actually needs to increase its heart rate in order to maintain blood supply to muscles because we don't have as much of it. What this means is that even though we're not working any harder from a pace perspective or a performance perspective, our heart rate is going harder or is going faster. So while our performance may not change in terms of how fast we're actually moving, our heart rate, we are working harder. And this is a problem because we can go above our lactate inflection point or we can fatigue faster. When we look at thermoregulatory fatigue, we can divide it into 2. VCAR have tended to focus on peripheral fatigue. Peripheral fatigue, remember, is inside the muscle. Central fatigue is at the brain level. So what happens when our body moves outside that temperature range, we get issues. And we get issues with the brain and with the firing of neurons. One of the reasons is that when our neurons fire and we contract our muscles, we produce heat. We want to decrease our heat production if our body temperature is too high, so we get a decrease in the brain sending messages to the muscle. It's a protective mechanism. We also become tired, we get a headache as well, and quite often if someone has a headache, the first thing I say to them is go and have a drink of water because it's linked strongly with dehydration. You might become tired and you might become confused as well in serious cases. This is all fatigue. At a peripheral fatigue level, when we get an increase in body temperature, our body sweats to cool down, we've established that, and we get an increase in the blood flow to the skin because it's trying to come close to the surface area that's being cooled down. Now, what does this mean? This has some pretty big implications. By increasing blood flow to the skin, we actually get a decrease in blood flow to the muscles. When we don't have as much blood flow to the muscles, we don't get as much oxygen to the muscles, which means we can't produce as much energy aerobically. So how do we get the energy if we can't produce energy aerobically? We get it through anaerobic energy systems. And this has a finite capacity, so this is a problem. More likely, we're going to get an accumulation of metabolic byproducts, hydrogen ions, as we get an increase in that anaerobic energy, and that in itself equals fatigue. The fatigue is within the muscle because hydrogen causes an increase in acidity, which affects glycolytic enzymes, which means that our force production decreases. And if our force production decreases, our intensity decreases. And that is fatigue. Remember, fatigue is an inability to maintain a given force production or power output. So dehydration and thermoregulatory fatigue is complex. I would definitely be focusing on that peripheral fatigue, but understand why central fatigue occurs as a result of an inability to maintain a given body temperature. If we look here at the link to dehydration, by not taking adequate fluids, that can result in dehydration. That's a really good way to combat dehydration as well, is to take in fluid. And we've got some symptoms there. And again, we're going over exactly what's happening. And that last dot point, the body overheating, enzymes won't function efficiently. As soon as you change your body temperature from outside the norm, things go wrong. It's a protective mechanism. Let's have a look at some sample questions. So the first one, during the Australian Open Tennis Championships in January, obviously we're looking at 2006, temperatures exceeded 40 degrees and players were susceptible to dehydration. Which of the following may result? Have a go, pause it, have a quick go at the answer. Okay, so when a player becomes dehydrated, we get C as the answer, a reduced blood volume and an increase in core body temperature. We do get a vasodilation of peripheral blood vessels as well, but that reduced blood volume is specifically linked. Now, nowadays, so not 2006, but almost 10 years later, they'll use thermoregulatory fatigue. Let's have a look at question 7. Other than depletion of muscle glycogen stores, what are the main causes of fatigue for endurance athletes? Again, pause it, have a go. We know that the A is wrong. PC depletion and lactic acid accumulation. A, it's not lactic acid, it doesn't accumulate, and PC is not associated with an endurance athlete. Dehydration, elevated body temperature. Yep, that could be the answer. Pyruvic acid accumulation and dehydration. No, it doesn't. Pyruvic acid doesn't accumulate. Increased levels of ADP and hydrogen ions. That's not associated with endurance athletes. So the answer is B. Again, they'll use thermoregulatory fatigue now. That's the more sophisticated term. That's the fatigue mechanism. Dehydration is the result. So how can we counteract it? What we want to think about is ways that we can counteract thermoregulatory fatigue or overheating is by making ourselves cooler. So we want to get our body temperature down. And all of the mechanisms you can see there are aimed to bring our body temperature down. Ice baths, cold showers or ice vests, and you'll see during particular sports that are played in really hot weather or even moderately warm weather, they use ice vests on the interchange, and afterwards they might have a cold shower. That really helps cool the surface of the skin down, and if the blood is going to that surface of the skin, it will cool down as well. They actually can have cool rooms or fans as well. Fans act like a wind, and that evaporates the surface of the skin. Going in the shade is a good idea because then you're not out into the sun, which decreases the ability of the body to self-regulate temperature, and also wearing light clothing as well. Light coloured because dark coloured absorbs more heat, and lightweight. So if you are asked how someone could counteract thermoregulatory fatigue, then these are the mechanisms. You can also have a cold drink as well. That helps too. Cold drink helps going into the stomach. Something else you might see when marathon runners are running, they might grab 2 drinks at a drink station. Let's say it's water, or it could be a sports drink. They'll drink one and they'll dump normally the water over their head. So have a think about how that aids in fatigue and which fatigue mechanism that is counteracting. All right, I hope that helped.